Okay, so we've been given this triangle. We know the coordinates of corner A and corner B, but we don't know corner C. We know the x-coordinate, it's 4, but the y-coordinate is called K, apparently, okay? And we have to work out the equation of this line, AC. There's a couple of ways. I'm going to show you how to do it. Doesn't matter which you prefer, just pick your favourite. The first way is this. We're aiming for the equation of the line AC. We can work out the equation of the line AB pretty easily because we know the coordinates of A and we know the coordinates of B. So we can work out the gradient, and we know that AB is perpendicular to BC, so we therefore immediately know the gradient of BC from the gradient of AB, it's negative inverse. And so we can work out the equation of line BC, and then in that equation of that line we just put the x equal to 4, and that will spit out the value of y at x equals 4, in other words the value of k. So, and when we've got k, then we can easily work out the equation of this line. So, don't worry if that didn't make sense. I'll just do it and you'll see what I mean. So, equation of the line AB. To work out the equation of the line, we need the gradient. So, the gradient is written m. So, I'm going to write it as m sub AB, meaning the gradient of the line AB, is the rise over the run, which is, the rise is, well, it goes from there to there, 1 to 5, so that's 5 minus 1, and the run is from -2 to 6, so that's 6 minus -2, which is 4 over 8, which is a half, okay? So the gradient of AB is a half. Now we don't actually need to work out the equation of this line, we just really needed the gradient because, like I said, we can now easily work out the gradient of the line BC. Because when two lines are perpendicular, and we've been told that these two are perpendicular, the gradient of one is always the negative inverse of the gradient of the other. So the gradient of the line BC is the negative inverse, in other words, -1 over the gradient of AB, which is -1 over gradient of AB is a half, which is, dividing again by 2 means 2 flips up to the top, so it's -1 times 2 on the top, which is just -2 over 1, in other words, just -2. Great, so we've got the gradient of the line BC. It's -2. And we know it goes to the point 65, so we've got the gradient and a point, which means we've got enough to write down the equation of that line. We shall use this form of the equation of the straight line. Y minus y1 is the gradient, m, times x minus x1, where m is the gradient and x1, y1 is any point on the line. In this case, we'll have to use 6, 5, because we don't know what that point is. We don't know k. So, y minus y1, we're using the point B. So y1 is 5. Y minus 5 is the gradient. Gradient is -2. X minus x1. The x is 6. -6. Okay? Therefore, y minus 5 is -2x. -2 times -6 is plus 12. So add 5 to both sides. Y equals -2x plus 17. Great! We've got the equation of the line BC. Okay? Now, the line BC passes through the point C, the one we're interested in. So if we put x equal to 4 in this equation, whatever value of y it spits out, that is the value of y at that point, which is k, so that's what we want. So we're going to put x equal to 4. Okay, and we get, at x is 4, y is k at that point. Okay, so we get y equals, or k, because y is k, equals minus 2x minus 2 times 4, x is 4, plus 17. Okay, so therefore k is minus 8 plus 17, so k is 17 minus 8 is 9. Excellent, we've got k. It's 9. So that's the hard bit done. Now, just to finish off, it wants the equation of the line AC. So again, we use y minus y1 is mx minus x1. Okay, so that was for the line BC. Now, for the line AC, y minus y1 is the gradient, x minus x1. Okay, what's the gradient of this line? Pretty simple. Where shall I do this? Here. The gradient of AC is the rise over the run. The rise is, it goes from 1 to k is 9, so that's 8. 9 might rise over the run. It goes from minus 2 to 4, so that's 4 minus minus 2, which is 8 over 6, which is 4/3. Okay, so the gradient is 4/3. Right, so the equation of the line AC, y minus y1. Like I said, the point x1, y1 is any point on the line. We can choose this one or that one. Doesn't matter, we know both of them. Let's choose this one. So y minus y1 is 1. Is equal to the gradient, 4/3, times x minus x1 is minus 2. Don't fall into the trap of only writing one minus sign there. There's that minus sign and there's that minus sign. They're two minuses. So let's multiply everything by 3 and multiply that out at the same time. So we get 3y minus 3 is equal to 4x plus 2 times 4 is plus 8. Right, it wants it in this form. So ay plus bx. So it's going to be 3y minus 4x. Let's bring the 4x over here. Equals, take the 3 over there. 3 plus 8 is 11. There we go. 3y minus 4x is 11. Good. Right. I'll now show you the second way how to do it using Pythag. So we're aiming for the equation of the line AC, and this time we're going to solve this problem using Pythag. So let's look at the line AB and imagine it as part of a right-angled triangle like so. Okay? Let's call this the distance from A to B. Let's call it x. Okay? Now, using Pythagoras, we can say that x squared is equal to this squared plus that squared. So, what's the length of this line here? It goes from minus 2 to 6, so that's 8 long. So x squared is 8 squared plus, how long is that line? It goes from 1 to 5, so that's 4. So 4 squared, which is 64 plus 16, which is 80. Okay, so x squared is 80. I'm not going to bother taking the square root of x because we're going to do Pythag on this triangle to get this, so we need it in the form x squared in the end anyway. So it's fine as it is. Right, same with this triangle here. Let's just draw that right angle triangle. Okay, let's call the length of line BC, let's call it y. Okay, again, Pythag, y squared is this squared plus that squared. So what's the length of that? We don't know exactly, but we do know that it's equal to k minus 5. So it goes from 5 to k. So it's k minus 5 squared, okay, because that's k minus 5, and that is 2, because it's from 4 to 6, okay, plus 2 squared, which is, okay, multiply out that bracket, it's k squared, minus 5k is minus 10k, minus 5 times minus 5 is plus 25, and you've got the plus 2 squared, which is plus 4. So that's k squared minus 10k plus 25 plus 4 is plus 29. Okay, so that is y squared. Good. Right, let's call the length of the line A to C, let's call that Z. And now we're going to do Pythag on the triangle ABC. So on ABC, Z squared is equal to x squared plus y squared. Okay? Right. So what's Z squared? Okay, I've jumped one stage. We need to do Pythag on this triangle. Okay, so it is z squared is equal to x squared plus y squared, but we need to do the same thing as before. Z squared is also equal to that squared plus that squared. So what's this distance here? Well, that's from 1 to k, so that's k minus 1. So z squared is k minus 1 squared plus, what's this distance? That's from minus 2 to 4, so that's 6 plus 6 squared. Okay, so z squared is, that's going to be k squared minus k minus 2k plus 1 plus 6 squared is 36. So that's k squared minus 2k plus 37. Okay, right, now we're ready to say that z squared is equal to x squared plus y squared, applying Pythag to the blue triangle ABC. Okay, so z squared is x squared plus y squared. Now, z squared is that, so therefore, k squared minus 2k plus 37, okay, and z squared is equal to x squared is 80, y squared is k squared minus 10k plus 29. Okay, and as you can see, we've got an equation in k, so we can solve it to find k. Right, well, first thing, we can cancel the k squareds, which is nice. So let's get all the k's on this side. So bring the minus 10k over here, it becomes 10k minus 2k is 8k. So that's that dealt with and that dealt with. Now we've just got numbers. So it becomes 80 plus 29 is 109 minus 37. 109 minus 40 would be 69, so minus 37 would be 72. Okay, so 8 times 9 is 72, therefore k is 9. And we found k using Pythag. So that's the hard bit done. Now the easy bit, equation of the line A to C is y minus y1 is the gradient times x minus x1. Let's choose the point C. We can choose the point A as x1, y1, or C, because that's 4, 9. We've worked out k. Doesn't matter, let's choose C as the point. So y minus y1 is 9. Is the gradient. What's the gradient of this line? Rise over run. The rise is from 1 to 9 is 8. And the run is from minus 2 to 4. So that's 6. So that's m times x minus x1 is 4. Okay, multiply both sides by 6. You get 6y minus 54 is equal to 8x. 8 to minus 4 is minus 32. So I want it in that form. So 6y, x is on this side, minus 8x equals minus 32 plus 54 is 22. Even, 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 so divide everything by 2 and we get 3y minus 4x equals 11. There we go. So that's how to do it by Pythag. I think the first method was quicker, working out the equation of this line, well, the gradient of this line, then the equation of this line, and then the equation of AC. But you'd still get full marks in the exam if you chose to do it this way. It's just a bit longer. So there you go. That is 2 different ways to solve this problem. Thank you for watching. I hope you found this video helpful. If you did, please click the like button and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drjem.com, and I'm also on social media. Thank you.